I'm Jim Crooks, the Master Blender for Firestone Walker Barrelworks, and I'm here with your craft beer and brewing tip of the week. So now we're going to talk a little bit about the recipe development and the beginnings of our exploration into what sour beer meant to us. From the beginning, we started off with a simple Saison recipe as a really good base canvas for really developing these flavors. I learned pretty early on was that if you're going to use Brettanomyces and lactic acid bacteria to create these flavors, then it's going to take time and there's going to be a degree of patience that's involved in the process. Beginning with the Saison recipe, we realized in the beginning that flavors that put into a recipe, you don't normally or necessarily get out of that recipe. Unlike when you're doing production brewing, there are things that you can add to your recipe in the beginning that will make it through the final product. But in terms of developing a recipe, in the beginnings, we were thinking what would be a great canvas to really accentuate what we thought of what our vision of what sour beer was, which was, complexity. And so we're always thinking what would drive complexity in a recipe, simplistic recipe. So in a Saison recipe, it's normally very simplistic malts, very simplistic hopping as well. From my days in the lab up in Paso, I did a lot of experimentation with IBUs and the suppression of lactic acid bacteria, and realized early on that in a lot of cases, the IBUs can be really low and still suppress lactic acid bacteria, even to a point where when we were brewing Hefeweizen, we would see the suppression of lactic acid even being achieved at somewhere between 12 and 13 IBUs. So knowing that, I wanted to promote the acidification of these beers, we would always focus on the IBU of these recipes being somewhere right about 10. Obviously, hops are an important part of the flavor and of the feel of these beers. So we would never go without hops, but I'd always choose hops that had a subtle amount of influence on the recipe. We would also find that not one recipe would really cover the basis of what we're looking to achieve. So in a lot of cases early on, we would always be augmenting our recipes to see what the outcome might be. It takes time. These were beers that were taking at least 16 months in barrel with the addition of Brettanomyces and lactic acid bacteria, a lot of times a mixed culture, to really come around to a point where you could start understanding what the influence was on how you changed the variables of your recipe. So we would start off by taking really good notes. We would only change a few variables of our recipes at a time. Say if we wanted to raise the degree of fermentation or if we wanted to lower the degree of fermentation, say we wanted a higher ending gravity, we would tweak our mash temperatures on a recipe and fill, say, 20 barrels. And we would inoculate with a certain culture of Brett just in those barrels and call that good. And that would be our experimentation for that. Slowly started realizing that we wanted to evolve and create more complex recipes that either brought in color, dark malts, roasted malts, maybe a lot more body into the recipes. So we would constantly be fooling with recipes to change the mashings, the program, raising the mash temperatures, not mashing low. So we were actually trying to stop fermentation and leave behind a lot more fermentable sugar that would eventually help activate a really good secondary fermentation in barrels. If you're to look at our program, one aspect would be a lot of development and experimentation on the recipe side in the brew house, and then also a lot of experimentation in fermentation to try either to slow down fermentation, temperatures of fermentation, try to stall fermentations, all in the idea that we wanted to have a lot of development in the barrel once the beer was transferred out of the barrel. The recipe development was a big part of the development of a lot of these beers, and the tweaks that we did with the recipe, either the mash program, the malts that were used, the lowering of hops, The primary fermentation became a very important part of our research, and at the beginning of this project we were using Saccharomyces to achieve most of our fermentation profile. Just because that was what I knew, what I came from, I had a real comfort level using Saccharomyces yeast. I felt like that would be a really good way to achieve a very quick base beer for these beers. And what I found, and this was what maybe took years to figure out after the experimentation the first few years, was that Saccharomyces yeast that was carried over into the barrel after primary fermentation was giving us some issues with off flavors. Even though there was a small amount of that Saccharomyces carried over, I think it was enough because it's more of a production yeast, it's more of a delicate yeast. It was dying off in the barrel and causing for autolysis flavors, and it was killing head retention on our beers as well. So I would say about 2.5, 3 years into the program, I made a decision to stop using Saccharomyces for our primary fermentation. To learn more about artful and intentional wild beers, click the link below.